Well, I am very privileged today to be joined by Todd Cramer, and he is Director of BD, Security Ecosystem at Intel, CCG Business Client Platforms. And we're here to talk about enhancing PC security threat detection with AI. So I wanted to say thank you for joining me, Todd. I'm really, really looking forward to digging into what Intel's doing at the moment over there.
Yeah, great to be here. It'll be a fun conversation.
Thank you. So would you like to just explain a little bit about what you do over there at Intel yourself?
Sure. I work in our commercial client division. So just think about, the PCs that you've gotten from Intel over the years, and there's hardware security inside of each and every one of our chipsets that goes on a PC. And to make that security come to life, in many cases, we need the software ecosystem. So my job is to help work with the security ISVs, the antivirus, endpoint detection response, all sorts of different kinds of security ISVs to understand what is that hardware goodness, how can they integrate and bring that to life in their solutions. So we kind of work together to build what security you have on your PC, right? It's a combination of the hardware and the software ecosystem.
Right. And you're talking about independent software vendors here, right?
That's right. Yep.
Yeah, just to be clear. So yeah, I mean, it's a pretty crazy place right now. We hear about all of these kind of cyber attacks that have been going on and breaches and all sorts of stuff. So let's talk a little bit about the threat landscape that businesses are experiencing in 2024. Are cyber attacks becoming more frequent and sophisticated? And what new kind of attacks are we seeing?
Sure. I mean, if you're close to the industry, and even if you're not, you'll see the headlines, right? They make your local news when a school district's been hacked with ransomware, or nation state actors hacked into our systems. There's no end to the types of techniques and sophistication that's going on. I mean, a couple of data points. I think ransomware is something that is evolved into not only just enterprises are targets, but small businesses and even people are targets of ransomware at different levels. And I think the stat is it just passed last year $1 billion in payouts. Right. And so that kind of damage is an economic damage at a worldwide scale. And so that's why you have so many different solutions trying to solve this problem of ransomware. So that's one of those. And then, with the advent of AI, now you're going to have this good versus bad, evil versus good use of AI. Right. And so some of those indicators that the attacks, AI based attacks are just starting. And just last week, there was a report that if in the field, there's something called, the Chat GPT-4. Actually, some lab testers were able to say, hey, if we give this AI in public access to inputs of known vulnerabilities on systems, could it actually figure out ways to hack in? And out of the 3 or 4 different algorithms they tested, they found out that that particular algorithm has a potential to instantly discover what's called 0-day or open vulnerabilities to be the precursor to attacks. So, the attacks haven't happened yet, but the potential is really there. And this research study is kind of opening people's eyes of, these automated bots scanning where you have a vulnerability to launch an attack. That's real. So.
Yeah, it's very worrying, to be honest. I mean, I think most people, until they've been on the bad end of their cybersecurity, they don't really understand how painful it is. To be honest, it's
Right.
kind of brutal. But at a really high level, before we get into too much sort of detail, how can Intel AI PC and the Core Ultra chip help protect businesses from these kind of attacks?
I'll go back to what I said at the beginning of the coming together of hardware and software. So you can think about it as Intel's going to put specific feature sets that work on their own or with the OS to help protect you against certain attacks. And then these other attacks or the optimizations for AI, we work with each of these software vendors that have different use cases for what they want to bring onto a client PC, whether it's anti-phishing, data loss prevention, core threat detection technologies. And so once they have this new AI MPU that we'll talk about and these XPUs, They have the hardware, the ability to run different types of AI on that client for different feature sets. So what you'll start to see, starting with this year, is more and more features being AI enabled right there on the client itself. So it's really just the start of an expansion of rebuilding some old feature sets in new ways, brand new feature sets, all AI based. So you're going to start to see AI move from the cloud only to being able to run locally on your PC for all sorts of use cases. That helps you as an average consumer when you refresh to a PC. You know it's got the latest technology, including the power of AI to help to get some of these threats.
Wow. Well, it sounds like there's a lot going on over there at Intel. I mean, it's so rapid, the development of technology at the moment. It's pretty kind of crazy, right? So how is Intel evolving its PC architecture to enhance security via AI? And what
Sure.
specific features and advancements have you kind of developed?
Yeah, so first off, you have to build the chassis or the hardware. There is no AI or software that runs. It all starts in the silicon at the silicon level. And so what you've had for years is you have a central processing unit, and then a couple years ago there was an integrated GPU or a GPU that's able to run and offload other workloads. And now with the launch of Intel Core Ultra this year, the addition of an NPU, a neural processing unit. All three of those is what we'll call our XPUs, and those are able to do different optimizations for AI. If you need fast inference for AI, it's a use case that needs fast inference, you're going to run it on the CPU, and Intel's got optimizations there to make that performant. Maybe you're running a machine learning kind of AI. Well, that's where you're going to offload it to the GPU, maybe the tool that you want to use as a software developer. Or the net new thing, what's different there is it runs the type of AI algorithms that are what's called deep learning. And those are the ones that take so much horsepower. They were only run in the cloud before. Now the MPU lets that run local. So you're going to see an ISV really take advantage of all three of those XPU architectures that we've evolved. And then Intel also helps build the software toolkits so that developers know how to take advantage of these accelerators, how to test for them, how to build their solutions around it. So that's what you're seeing this year is the flurry of activities really to just educate these ISVs, these software vendors about the new capabilities when they make choices of when to run it on the CPU, GPU, or the NPU.
Wow. Yeah, I mean, I did a bit of research before I talked to you about this, obviously. And it's actually quite an exciting time right now when you're thinking about having localized AI on your machine. So did you want to talk a little bit more about the Intel strategy for AI across its architecture from CPU, GPU, and now NPU, or are you kind of done on that one?
No, we can expand a little more. And
Oh,
Intel's
super.
broad enough where we have the silicon, the Xeons, right, that run the big workloads in the cloud or at an edge networking device. And then, our Intel Core Ultra lines that run on a PC. And then we still have other lines that run in industrial devices. So, AI is going to run in combination in the cloud. There's still a need, and most of these security vendors like Defender or CrowdStrike, they're made up of a big, large data lake and back-end threat graphs. That's the heavy lifting. It sits on a big iron in a server and does all of this analysis. It gets fed the data, and then it determines what to remediate on a client. Well, now you're going to have the ability again to run that AI in combination. Certain use cases will do some of that starter analysis right on the endpoint and help feed more targeted data to that back-end cloud, right, for analysis. Or maybe it's got enough that it can make a complete decision to remediate itself, all self-contained on your client. So there's lots of combinations of how this is going to work. And what's exciting about it all is, when you think about what you as a PC and all that data you generate on that endpoint, it's impractical to send every last bit of data and record it up to a cloud, right? And so this lets you put AI closer to the detection source where all that great data is to do good. And so that's what you're going to see here is a new groundbreaking way to find new threats, evolve new threat detections, because you can run that AI right with that AI on client. And more importantly, for you as a user or an enterprise, your data is kept private. It's not sent off to the cloud. There's no round trip latency or speed problems. there's a number of benefits by running AI local on the PC. And that's what we're excited about, this new paradigm to get all of the AI working together in different use cases together for the good of an enterprise or an individual.
Yeah, I understand. I understand that, because the faster you can detect anomalies, right, the faster you can actually deal with them. So if they're obviously in the endpoint, it's going to be quicker, isn't it, than going up to the cloud and then kind of back down and all this kind of stuff, right?
Exactly. And, one of the vendors we work with, CrowdStrike, and all these vendors put out annual global threat reports where they track key metrics. And, they have a metric on dwell time. How long does an attacker sit and lay wait dormant on your system before it launches attack? Or what's the time it takes to move from one PC in the fleet to break out to the second PC or the second part? That's down to about 70 minutes. So when they launch an attack, if they so choose that they wanted to move laterally, they could do it in roughly 70 minutes. And they've even seen it down to 7 minutes in certain cases. So that tells you the speed when you talk about an enterprise and their security software tools, their red teams, their SecOps, how quickly they need to respond. And that's another part we'll talk about later is SecOps and AI, and why this helps analysts triage those incidents faster, because it's already beyond the scale of humans. Imagine that something got in your system, you've got 7 minutes to go find and discover that threat before it breaks out and gets across the PC fleet. So it's already beyond the scale of humans, and that's why we need AI, right? So
Absolutely. If you're busy and you maybe you go away, make a cup of tea and come back, and it's 7 minutes is gone, right?
right.
It's fast. It's very fast. So what is Intel threat detection technology, and why is that a significant breakthrough?
Sure. Yeah, we're very proud of that. It's still one of the only cases of the early cases where you've seen machine learning already on client. About 6 years ago, we proved out what we did is there's telemetry off of your device in your silicon. And that CPU telemetry is used for classic reasons for developers to debug, to look at their application, see how it's performing on the chip. Well, somebody at Intel had a great idea to say, well, can we use all that great data to fingerprint malware, and specifically ransomware and cryptojacking attacks? And the answer is yes. And so what we do as Intel is we build machine learning in our labs for all the variants that are public and not public around ransomware and cryptojacking. We model that in AI. We offload it to the GPU that I talked about earlier, and we work with the security ISVs like Defender, ESET, all these ISVs to package as part of their solution. So they get a lens onto that unique telemetry, and it helps them, they find ransomware and these threats without us, but this gives them a unique lens because the malware can't hide. It can obfuscate, try to do things in software in the OS, but it has to execute on the CPU, and that's where we're going to find it. And so it's a detection assist, so to speak, that these software vendors, when you load their agents on an Intel PC, you're getting better threat detection. And in one of our studies, we found out that it had about a 24% detection assist increase by just deploying it on an Intel machine. So that's a differentiator for Intel, and that's what it is. And we continue to evolve that threat detection technology into the future.
Wow. Yeah, I mean, I've heard a lot about your labs because my sister used to work there for nearly 20 years, and she was involved with all sorts of things over there. But it's an amazing company, really, absolutely amazing. So can you talk specifically about how the vPro environment, along with the Core Ultra architecture, support the use of AI for endpoint security, please?
Sure. I'll just sort of classify it in security. You want to do something called defense in depth. And security isn't one thing. Attackers are going to try to get in the OS layer. If they can't get in there, they're going to try to get into the firmware. They're going to try hardware attacks. They constantly try all of that. So you have to have all the doors closed as best you can, and even have features that may be redundant, because if one feature fails, you have another one waiting to try to detect that. So with vPro, we have a whole bunch of security that's even non-AI based, that does a secure and protected boot, launches the OS in a secure way, looks for certain attacks. And so that's one level of security you want that vPro provides. And now with these EDR vendors, you're securing the OS, and you're doing it better with our hardware security. So you want this defense in depth across all the layers to build a holistic, best-in-class approach on it. So vPro, we like to position that as providing a lot of all the other pieces that you need, even in addition to the hardware-assisted pieces that we work in the OS. So.
Wow. And vPro is a separate platform, right? That is in the cloud, just to sort of, because some people may not know what vPro is.
Actually, let me better explain it. So it's what we
Thank you.
name the hardware security on the client. So in an Intel Core-based PC, when you buy a vPro, which is our best-in-class SKU that the OEMs build, it has your best security, your best manageability. The enterprise will usually buy a vPro system for that regard. So it contains a whole bunch of, I think it's over 20 features that get implemented by the OEMs for the firmware security, by Microsoft to build their virtualization-based security, and then by these EDRs. So it truly gives you that defense in depth, and it's available on client, and it works in conjunction with these other software layers.
Wow. So can I just ask you what an EDR is? Sorry, I lose my mind when it comes to.
Antivirus is the old name for it. You can
Right.
think of your old Norton antivirus, your McAfee, but then this kind of evolved in more sophisticated tools for an enterprise, endpoint detection and response. It just extends antivirus into new ways for SecOps teams to help find threats.
Thank you very much. I just have so many different acronyms going around in my brain that I need to ask. If I don't
Sure.
ask, I just kind of lose track altogether, really, you know. So why are hardware performance accelerators particularly important for cybersecurity?
Sure. I mean, this goes a long way back. When you have optimizations for certain functions, they can get better, right? Cryptography, it involves a number of keys, and it is highly compute intensive, but keys are what builds your secure authentication event when you log in. These are things that are the baselines for security, and we have accelerators for cryptography and encryption that are right in the hardware to accelerate that software the best it can. Or for things in like Intel threat detection technology, we have an accelerator there for memory scanning. So a lot of these threats will try to not deploy a piece of malware that's easily scannable on disk. They'll deploy straight into memory, and that gives these antivirus vendors a lot of trouble because they have to look through that memory layer, which is compute intensive. So when they do that, you can offload that computation from the CPU to the GPU to let these vendors scan more, detect more. There's all sorts of examples, but we work through where we can find an edge for a security feature. We'll try to build an accelerator and hardware for it to make it work functional and better. Because you as a user, you don't want your machine slowing down when your antivirus tool pops up. You want to go about, do your work, let security do its thing in a performant way in the background.
What are some of the benefits of endpoint security versus security via the cloud?
Sure. And again, I'll go back to some of these studies out there. When you think about all that data that's resident on that computer, right? I think there's a stat that 85% of all the security forensics that's going to uncover a threat comes right from your endpoint. So we know it's the golden data source that has, all the pieces and that interact with you as the user, and that's where threats come in, and that's where all the data is. So endpoint security first has that special place, and endpoint security also is the thing that feeds these cloud backends. So you need to get it very performant in how it communicates securely with those cloud backends, what it's looking for. You remember there's AI on the cloud, you need to feed it the right information. So I think, again, back to our discussion on AI, putting AI on the endpoint is going to help feed the cloud more of what it needs to do its job better. It's going to have unique protections for you right there on the endpoint, keeping your privacy, your data, so it doesn't send it to the cloud. And all those benefits we talked about earlier. So it's just unique advantages of getting endpoint security. Your PC has a very important role in the overall security, right? So I think that answered what you're looking for.
Yeah, absolutely. And obviously then there's a sustainability kind of arm, but we're not going to go into that because that's a whole nother topic, right? Like
Sure.
it's massive. And I know you guys are doing a lot to kind of minimize the environmental impact with all of this. because it does reduces the amount of power used and all that sort of stuff, right?
Absolutely.
Yeah. So do you have some more data to show how and why this silicon AI approach is impactful for SecOps and IT?
Yeah, I think again, I mentioned before that threat detection technology that's AI based, right? It uses our telemetry to find ransomware. We had a vendor, SE Labs. They test a lot of these security applications, and so we gave them a PC with the TDT capable, and one of those antivirus software vendors that has had the features in it, and so they put it through hundreds of tests through all the top ransomware strains to say, well, what did this sensor? So they cut off the EDR and looked at just to isolate the sensor, and their data came out with 93% of those ransomware attacks were discovered right from that threat detection technology. You know, when you combine it back where it lives with the antivirus, you know, they'll get that coverage rate up to 98% of attacks for ransomware, software plus hardware. So, you know, it really is meaningful, does unique properties for that software vendor, and increases the overall efficacy, right? You want your hardware working with that software so you get the best detection assist that you can. And so that's one core data point. And another sort of data point that we have is, you know, we looked at, when I talked about that Intel vPro hardware shield, all those other security features in silicon, and we looked at a modern PC latest generation processor compared to one we put out 4 years ago. And we found that, you know, it's had roughly a 75% improvement in the attack surface because we're constantly putting out new features. And so when you compare a 4-year-old Intel PC with a modern one, it just keeps getting better and better to close these attack surfaces. So, you know, we like to track those things. It shows our improvements over time. And those are just two sort of factoids for you.
Thank you. That's fantastic. So how is Intel supporting the developer community in terms of enabling them to take advantage of these hardware features?
Sure. Sure. I mean, Intel works across. There's actually, you know, Intel's one of the largest software development companies by number of developers that work for Intel. So every time we bring out a new processor, we work years ahead of time with not only the security software vendors, that's my job, but the OS, the tools, all WinML, all the things that, as we've talked about with AI, these developers have to train AI in the cloud. They have to see how those models and AI work on a client, how fast it's inferring, how is it, you know, these are all done through AI software development tools. And one of them Intel has is called OpenVINO. So we work to get the software tools optimized, our own and others, so that no matter what framework a developer chooses to develop AI, we've got those accelerators, the optimization ready to go in the tool so these developers can take advantage of it and then just, you know, have their software work on Intel PCs to the best regard it can. The other thing too is, as we work with developers, it's not just the software, they need to validate it and really see it on the hardware itself. And so we commonly ship out early systems and loaners, and now we have a software development kit for developers on Intel Core Ultra so that they can able to run through a series of applications to understand how the NPU works, how the GPU works, how it works with their software. So it's all part of that tooling that Intel provides the developer community.
Wow. I know you guys are doing huge amounts of great stuff. I went to the museum a few years ago, and it was very impressive, to be honest. So, as far as cyber criminals are concerned, you know, they're doing a lot with AI as well to carry out a lot more sophisticated attacks. And I mean, I was going to say, is this something of an AI arms race? But I think it is an AI arms race when you think about rogue states and kind of all that sort of stuff. So
Yeah.
how can you ensure that the good guys stay ahead, Todd, with this?
Oh, sure. I mean, sure, there's, as I mentioned before, new and evolving ways that they're going to use AI itself to attack and analyze systems and what have you. But, you know, AI for good, the communities, you know, we have the advantage of sharing attack techniques as an industry, right? When someone sees a technique, there's open sharing so that others can develop protections for it. There's things called MITRE. MITRE is an industry organization that helps model out attacks to AI. And we just, as Intel, just joined one of those projects called Project Atlas. And it's what it does is define every known method of attacking AI from its creation to its inference stage, and mapping those out. So we as an industry are putting our heads together, competitors together, for the good of the industry, to help figure out what are the ways they could attack, and where do we have existing solutions, and where do we need to build new ones. So there's a lot of force for good out there in trying to turn the tide on things. And then ultimately, as I mentioned before, security already has thousands of alerts these enterprise SecOps teams need to deal with. And so that's where you're going to see, and we can talk about a little bit deeper, the AI SecOps assistant, the tools that they use to be able to have a better interface for those analysts to triage events and do a number of things. And so AI is going to play a role in developing as really the interface for security tools themselves, and it already is.
Have so much work, and they have so many machines, so many operating systems, so many applications, and all these problems. It's very difficult for them to actually prioritize. So I'm sure that the AI will really help with that for sure. So how does the public at large, the non-tech experts, benefit from the fact that we can now use AI to combat cybercrime?
Sure. I mean, a lot of it you're not going to see as a user, right? Behind the scenes, when you do your daily business or work as a creative person, just know that there is a lot of those security functions are AI based, and some of those are running right on your PC, right? And so just knowing that when you buy it's good to refresh your PC, right? I think enterprises do it every 3 years, they refresh their fleets, but you as a user, getting the latest generation, and I'd say this Intel Core Ultra, the new one, has that third neural processing unit. So you're going to start seeing AI-based security features that only work on these modern generation systems. So for you as a user, you just need to know, get the latest, and that AI goodness is in there. And as things move forward, I've even seen vendors on the consumer side where when you interact as a user, there may be some dialogue that comes up to you, as a chat bot, to tell you what's going on in your PC or how you can do something to be more secure with a more interactive dialogue, right? And so you're just, AI is a tremendous interface for non-techie users or technical SecOps users. And so I think you're going to start to see that for the users as well, is they'll be a part of the security equation to help keep you protected and safe.
It's a very exciting time. I'm getting really geeky into this, to be honest. It's too much. So we're just beginning to see what AI can do, really, from a security perspective. Where do you see things heading in the next few years, and what's the big innovation, the next big innovation on the horizon, do you think?
Sure. I mean, as I mentioned before, right now we're at the point where this AI for security on endpoint is just starting in the last year. And so that's helping increase detection efficacy, helping do better data loss prevention of information. All sorts of things are just happening now to build that edge for an AI PC. And then from the enterprise perspective, the SecOps and red teams, they have these new tools that we talked about. And so today it's helping them triage alerts, helps them triage incidents faster. But where that's going to go on the enterprise side is the ability to almost heal infrastructure on the fly. So you can imagine an analyst who says, okay, we're seeing this type of threat across these devices. I've just seen that happening. Now, how do we close that vulnerability? And they'll be able to, verbally command, and instead of creating a project to create an integration code to get that thing fixed, they'll be able to have the generative AI generate code to fix that environment directly, because AI can generate code, right, and generate scripts. So it's really going to become this functional piece of healing infrastructure right at the command of the SecOps agent. So that's going to be pretty interesting to see. And then, we're going to see more of this, especially in the area of like deep fakes as an individual. Are you really in the age of information age? Are you really talking to the real person, or is that a video reel or not? Already you're going to start to see things that tell you whether something is AI generated or real or not, right? And that helps you protect your own security around that. So lots of those things right around the corner, and it's pretty excited to see where the experts take it.
Yeah, I'm excited about that. The UK published a law fairly recently on that, saying that if you actually generate deep fake videos of people, even if you only have them on your machine, you can be prosecuted. So I think
Right.
that is, I think that, when all this regulation kind of catches up, then we're going to be having another conversation in a year, 2 years time about something else completely different, right? That's going to
Right.
be, coming on, because they're always going to be a step behind, because they're not techies, are they, these people? So we talked a little bit about the AI assistants. So how does the emergence of AI assistants for SecOps tie into things that Intel is bringing up on the endpoint, and also zero trust?
Yeah, I mean, it's in one simple way. If you have AI working on endpoint that finds these threats, those are the detection incidents that flow through to the SecOps assistance that the security teams are using. So they'll be able to surface that and understand, on my AI-enabled PC fleet, am I seeing this type of attack? And so that detection assist it provides will help surface that for better security. So that's one way to look at it. Um, um, it's just also in areas like zero trust. There's this concept of zero trust in the security industry, and it says, before, if I'm an enterprise user working remote and I've got to access Salesforce, a SaaS app in the cloud, I'm outside of the traditional enterprise firewall protections. So it puts it more important on assessing two things: authenticating the user, who they are, and two, the health of the device. You don't want to have a device that's infected with various malware, et cetera, and give them access to corporate access. So zero trust is a way of being able to score the trust of the user and the device. And so you're going to see all these things that I talked about earlier help score the health of your device before you log into Salesforce. So it's going to increase that ability when you're a remote worker, based on that hardware security that I talked about earlier.
Wow. Wow. So how are you working with the security industry to further your unique approach over there, Todd?
Yeah, I talked a little earlier. There's lots of industry consortiums. Intel helped start the Confidential Compute Consortium. Um, there's also MITRE. We're involved with 2 projects there. There's constantly get-togethers right coming up here as RSA in San Francisco. All the security experts head to that event, share ideas. So we're very visible in different ways that we can to further security across different parts, different attack vectors on the server side or the endpoint or IoT. We're involving help steer and move those things. So then there's others like us at an IBM or what have you. The big guys get together with the little guys and try to improve the security attack surface, if you will, across everything.
Fantastic. Well, I'm really excited, and if you're watching this, you'd like to learn more about what Intel's doing, I will drop a link somewhere around. It'll be at the bottom of the video, or in the newsletter, or the blog, or wherever you watch this or listen to this. So I want to thank you very much for your time, Todd, and thanks, Intel. We appreciate you guys and what you're doing here.